Here they tell us to write a linear equation for each table relating x and y. So some of these, we can extend the tables to figure them out. Don't be afraid to do that. Don't be afraid to rewrite them or work backwards or forwards, right? Building up or down with x, because you might not see the pattern right away. But I guess one thing that's wonderful about this is we know they're all linear equations. So we'll talk about how to use it to our advantage in a moment. But in the first one, they tell us that when x is 0, y is equal to 2. Now, if all of these are linear equations, that means we can think of them as y equals mx plus b, where m is your slope and b is the y-intercept, where the line crosses the y-axis. Now, thinking of them in this form, think about what they're saying. When x is 0, y is 2. Well, y is equal to something times x, but x is 0, so it's m times 0, plus something equals y. But they just told us when x is 0, y is equal to 2. So when x is 0, m times 0, that's just 0. Plus b equals y. So the question is, if we know y equals 2, what does b equal? Well, 0 plus b is y, right? Which means b is equal to y. And that y is equal to 2. Since b is equal to y and y is equal to 2, then b equals 2. Right? This tells you that the y-intercept is 2. So in any of these tables, like here, x is 0, y is 20, and here, x is 0, y is 20, that means your y-intercept is the result of y, is the y value itself, excuse me. So when x is 0, the y value is the y-intercept. Now on a graph, you can think of that, if you set up a graph right here, this is a point, 0, 2, because they say x is 0, y is 2, right? So it's that point right here. Next, they say when x is 3, 1, 2, 3, that y equals 8, 3, 4, 5, 6, 7, 8, right? This point right here, and so forth. But we don't need all these points. I'm just trying to highlight that, when x is 0, the y value is the y-intercept. So we can connect these two, right? So we can find the slope quickly now in several different ways. You can find the slope between 2 points, or just, look at what's happening. When x is going up by 3, y is going up by 6. And that happens every time, right? So here's 2 ways to think about it. The slope is equal to change in y. How much is your y value changing for every change in x? It's a ratio. We just said that the y changes by 6 for every 3 x's, and that's just 2 over 1, or 2. That's our slope. Another way to think about what the graph is, okay, to get from one point to the next, I have to go up 6. That's my rise. And then over 3. So it's up 6 and over 3. Slope is just rise over run, and rise is this number. Run is this number, which I cut off there, sorry. Run is the value 3. In other words, how far along the x-axis do we move? And that's your slope, 6 over 3, to get from one point to another. And we could just have subtracted the points as well. Formerly, the slope is usually written as delta y, where we have the y values in 2 points subtracted over the x values in 2 points subtracted. These aren't exponents here, little numbers. It's just a reference, right? 2 points. If we had these 2 points right here, I'd say this is equal to y2, and this is equal to y1, and this is equal to x2, so x2, y2, and then x1, y1 is this point right here. So we subtract the y values and subtract the x values, which is 8 minus 2 over 3 minus 0, which gives us the same thing. I'm just showing you a lot of different ways to think about this. So putting this all together, our answer for the first one is y equals 2x, because the slope is 2, right, plus 2. And you can test it out. If you plugged 22 in this formula, you should get 10. You should test these out, especially when you're newer with this, because, reverse that, sorry, plug in 10 and get 20, right? You plug the x value in to get the y. Especially when you're new at this, because you don't want to mix this up. So anyway, if x is 10, what happens? Well, then y equals 2 times 10 plus 2, which is 22. So it's working, right? When we plug in 10, we should get 22. That's our first one. The second one's actually very similar, right? The y-intercept is 20, right? Plus what? Well, how does our x and y change? Well, I noticed that when my y goes down by 12, my x goes up by 3. Here, when my y goes down by 4, my x value goes down by 3 as well. Down, look what I just did it there, sorry. 8 to negative 4 is another 12. They got me right there, right? So again, when x goes down by 12, the y goes up by 3. So that's actually a little bit different, but not that much actually. Here the slope, if we write it over here, let's say, slope is equal to change in y over change in x. Well, the y value is going down by 12, so subtract 12, or negative 12, over positive 3. So your slope here is negative 4, right, over 1. You just simplify that. Now, on a graph, right, just set up a rough graph right here. We know our y-intercept is 0, 20, all the way up here. This just means that for every time I go up once on my x-axis, I go down 4 on the y, so maybe right here. So a negative correlation or slope. As x increases, y decreases here. And it's a pretty shoddy graph, but I think you might get the point there. So this time our equation is 20 minus 4x equals y. You could have written y equals negative 4x plus 20, same thing. I'm going to work with part D next, but I'm going to rewrite the table down here so you can see it. Now D just says that x equals 0, 3, 6, and 9, and then the corresponding y values are 20, 11, 2, and negative 7. So again, this is a linear equation, so we're looking for a constant slope. As x goes up by 3, y goes down by 9, and this happens every time. X is going up by 3, and y is going down by 9. So slope is that change, right? The y value goes down by 9, and x value goes up by 3. This equals negative 3. Our y-intercept is 20, so y equals 20 minus 3x, or negative 3x plus 20. And you can plug these x values in to check, see that you do get the y values. Now our last table, the only difference here, part C, is that we're not given directly the y-intercept. So let's just work that out. So the x values are 2, 4, 6, and 8. All right, x values are 2, 4, 6, and 8. This is part C that we're talking about. The corresponding y values are 5, 8, 11, 14. 5, 8, 11, 14. Okay, so what's happening now? Well, I said earlier that you shouldn't be afraid to, work backwards on a table. So I want to show you what I mean right here. Okay, so make sure we move this over. So backwards, and I'm just talking about the idea that, we can look at this. We can look at and predict what will happen as x decreases. So if x is 1 and 0, what should happen? Well, first I look at my pattern here. I notice that when x goes up by 2 each time, y is going up by 3 each time. So here we can reverse that logic. If x goes down by 1, y should go down by 3. And it does, right? And again, here. So in this way, right, we get our y-intercept pretty quickly. It's just a quick, intuitive way to do it. And there are many other ways, but with this table, this seems to make a lot of sense. So the y-intercept is negative 1. So y is equal to what? Well, your slope is, we said before, if x goes up by 3, y goes up by 1, y goes up by 3. So slope equals delta y over delta x. It's, how is the y value changing compared to how the x value is changing? Well, it's 3y's change for every 1x, or 3. So y equals 3x, right, minus 1. And that's our final, I think, equation for our graph, for our table that we're given. All right, hope this helped.